Edmund, please start with your presentation.
Thank you, Gary. Welcome, everyone. Hello to all the world. I know that there are participants from Australia, China. I see a lot of people. I'm happy that you all joined for today's webinar. Umbrella for the water loss specialist group. Okay, I will put on my pointer so that you can see my pointer as well when I want to show something. And see if I can switch my slide. Yeah. Okay, so I'm from the company FAST GmbH. Who doesn't know us? We are experts in leak detection for mainly water pipes, but also other pressurized pipeline systems. We can detect leakages there. To give you just a rough overview about our activities, we design and manufacture. So we are a manufacturing company. Like I already introduced, for all kind of leak detection equipments and solutions for water networks since 1986, so quite long already in the market. Over 34 years now, 35 years almost. We have about 35 people working in our company, and we are active in over 40 countries worldwide. And below here you see some of our tools and products we offer. I will not go into the details here because we want to focus today about the tracer gas leak detection. Okay, but to go a little bit to the background of leak detection, I want to show this slide from the IWA about the terminology of water losses. I think everyone who is in the field knows this. And the part which you see here in red is actually the one we are focusing the real losses. This is something we can provide tools and technologies for to successfully locate such real loss leaks in the network. Okay, then we also have developed this kind of nice pyramid. We call it pyramid of success. You see here on the baseline, on the base, you always have some indication that you have a leak in a water network. Then we step up in the pyramid and we do a monitoring of the network through either the loud silent noise principle. Then you know already a location or a section of a pipeline which has a leak. If you don't know where the pipe is, this is usually the next step, or before you start pinpointing and really locating the leak, you need to know where the pipe is going. So we can also do pipe and object locating with our solutions. And then we do pre-location, either with noise loggers, like with the loud noise silent principle. We also provide correlators. This is kind of already one of the last steps, but we took it out of the pinpointing mode because it has a very sophisticated background and is a technology which needs special skills as well. And at the end, always we focus on the pinpointing because we want to know exactly the location where the leak is and dig only area necessary to repair the damage, not larger. Okay. this is the same pyramid, but with some of our equipment we provide. You see here on the monitoring, on the baseline, we provide flow and pressure loggers and also noise loggers to deploy in the network. We do provide for the pipe searching step, PWG for non-metallic pipes, but also metallic pipes. We use a pipe mic for inserting to trace the pipe as well, flexi trace kind of. We do object locating with a metal detector. All this is in the step of pipe searching. For pre-locating, we also do listening sticks, either manually or acoustically, electronically amplified. Manually is also acoustic, but the others are all electronically amplified signals, so it's easier for the operator to hear. For correlator, we provide either stationary ones built inside cars or mobile ones to take out to the field, like only hanging around your neck. And for pinpointing, we have this kind of solutions with geophones, which is the most common one. Then we have also pipe mic, which is a unique solution developed by our company and by me actually. And last but not least, in the last resort, we use tracer gas for pinpointing leaks in the water network. And this is my presentation about today. I want to show you the application of tracer gas, what you need to be aware of, so about the limits and borders of this technology. Okay, for the solutions we have for tracer gas, we use our AquaAMS 300 or the gas check, which is only hydrogen sensitive sensors we're using there. So we cannot detect helium or other gases. I will introduce why we only use hydrogen for tracer gas leak detection later on. Okay, when to use tracer gas, important. So we say it's a solution of the last resort if all other technologies fail. We have at least some other technology which still can pinpoint your leakage. And one of the main factors is always the ambient noise, especially in large cities where you have 24 hours traffic, pumps running, air conditioners, and so on. So these noises are always louder than the leak sound, and you cannot detect or pinpoint the leak by the acoustic principle. And therefore, tracer gas is here one of the last. I say one of the last because pipe mic could be also a solution in this situation. But tracer gas was, before the pipe mic was developed, the last resort for very noisy environments to detect and pinpoint, not detect, but pinpoint the leakage. And another one example is pipes in very large diameters. You know, and probably have heard if you followed all the webinar series of the IWA and also our series of webinars, that as larger the pipe, as poorer the leak sound gets propagated through the pipe material. So either you use special designed hydrophones for correlating such leaks, or you use then also tracer gas, especially in very large pipes. This is very poor for the leak sound propagation, and even hydrophones cannot pick up the sound there. And then tracer gas is the last one of the last technologies besides of pipe mic to pinpoint this leakage there. Then also, you know, the problem of plastic pipes. They also are very poor in propagating the leak sound to the next accessible point of the network. So usually you also don't hear anything there. No signal for correlating, no signal for maybe ground microphone, but this usually, if you don't have an area where the leak might be, it's very hard to go also with the ground microphone for a very long distance and listen for the underground leak sound. Therefore, in plastic pipe, tracer gas technology is used also widely for the pinpointing of the leaks. Yes, also if you have very few access points of your network, it's too far apart that you can correlate on that pipeline. It's last resort step to also use the tracer gas there, because if there is no signal, you will always be not able to correlate on such sections which have very long distance in between. I say here more than 1,000 meters, but of course it can be also a little bit less. It always depends on the situation. As most of you I know probably have already some background in leak detection. This is something I have to say here. Every leak is different. So we cannot compare one situation with another. Therefore, each leak needs some special thoughts, some special approach to detect. So if one technology and solution was successful within your network, doesn't mean at the next leak it will be the same and very easy, but just for your information, leak detection is always a learning process, and therefore we also have such a wide variety of technologies to just cover all these demands and even pinpointing the leaks within the hardest environments and conditions of the pipelines. Okay, then also tracer gas or other technologies rather than ground microphone and correlators can get used or should get used if you don't know the material of your pipeline, or maybe there was even some repair done already and you cut out a section of the pipeline and you substitute it with another material. So this will give you already a big failure if you correlate this section. You see here with only on a steel pipe, which has a sound velocity of 1,300 meters per second, and you cut out a section of 2 meters and substitute it with a PVC material, which is very common nowadays. I see that very often. But this section only has a sound velocity of 350 meters per second. So in real, the leak would be at the 25 meters. No, 30.4 meters, but with this section in between, the correlator will show you the leak at 25 meters because of the difference of the sound velocity. And if no one noted in your GIS map that there was already a section cut out and replaced, then you won't have this information when you do the correlation. And therefore, you might get misleaded when you dig there, where the correlator shows you a very nice peak. So this is very important information, especially for correlation. But this is another topic, and I think one of my previous presenters in the IWA webinars already talked about that. Yes. Of course, also if you have unknown pipe material, if you don't know at all what material is buried, maybe very old maps or some bad construction and reporting of what they have been doing there, which is also in the reality often the case. Even in Germany, we have quite good water infrastructure, but a lot of municipalities, they don't know exactly what material is buried, and they don't record what they have been doing in their network, especially repairs and so on. So this is also the last resort with tracer gas or pipe mic besides to then really pinpoint the leakage in this kind of conditions. Okay, now I want to talk about the tracer gas itself, why we use hydrogen rather than other gases for this kind of application. So first of all, hydrogen is the cheapest option on the market. It's the smallest molecule as well. So it diffuses eventually through all kind of materials, even very solid surfaces like concrete or asphalt will be penetrated by the gas and will come up. So it's also an advantage. And compared to helium, we have shown here, it is very cheap. And also has some other advantages I will show in my next slide. So yeah, helium is also, besides of expensiveness, not, but maybe also everywhere available, but formula gas we usually use for the hydrogen gas is widely and broadly available worldwide for welding. It's a shielding gas. So we use a mixture of 95% nitrogen and only 5% of hydrogen, not pure hydrogen. This is dangerous and very, very bad if you would use that in your water network. So always make sure that you use lower than 5% mixture. Otherwise, you might harm yourself or others if you use pure hydrogen. Yeah, and also the formula gas is widely available. Like I said, it's getting used for welding. So the hydrogen is the superior solution of the helium or other gases. I already talked about that. But we also don't need to do any special treatment. So we can directly use the gas out of the bottle, out of the tank, and introduce that into the pipeline, and pretty easy to use and apply for this kind of pinpointing step. Also, another advantage of hydrogen is that there is no background concentration, or very few background concentration, so low that it's not detectable. I have to say here, old diesel engines, for example, they also emit hydrogen when they drive by, but this is like a small cloud usually, and it diffuses really quickly. So if you detect leaks on a road where you have all these diesel engines driving by, don't get misled by a small cloud of hydrogen getting exhausted by diesel engine, but stick there and try to continue the measurement and verify that this position was really a high concentration caused by the leak below, and the tracer gas which you introduced escaping through the leak. Usually you have then a concentration which builds up, and therefore this concentration should be there for a long period, not only like a few seconds, which would happen if a diesel engine drives by. For example, helium has a higher background concentration, which is detectable. So therefore, it's also not the superior solution or gas to use for tracer gas. Another advantage, like I said, is it's the smallest molecule. It diffuses eventually through all kind of materials. So it comes up through the ground very quickly. So you don't need to wait such a long time than you would need to wait with helium to come up. And it also doesn't build up very high concentrations in an area. Usually pinpointing, it says already the name, is that you pin out the exact location. And if you have, for example, a helium tracer gas, and you leave it, usually what is very common with helium tracer gas, you introduce it into the pipeline and you wait. Maybe you even come at the next day and you detect then the leaks. But if you have large leaks in the area, the tracer, the gas accumulates at this position, and in the end you have a huge carbon of helium gas in this area, and it's not possible to really pinpoint the location anymore, but you will have high concentration in a wide area, so you are not really much further than pre-locating. So yeah, this is just for your background information, the comparison about the different tracer gases. Those two actually are the one which are recognized by the IWA. Also here in Germany, we have DVGW, which is a German Gas and Water Association, which is doing the regulations for the German water companies. And they also recognized and have approved that two gases are able to use for tracer gas leak detection. But with this, what I have just explained, the comparison between the two gases, with hydrogen being the superior solution. Okay, I also talked about the dangerousness of hydrogen, which always comes up if we talk about hydrogen. So therefore, we use this mixture. This is very important, and I have to make sure always, if customer call me what gas they should use, that they use this mixture. If you use higher mixture than 5% hydrogen with 95% nitrogen, it will be flammable, it will be dangerous, it might be explosive if it accumulates. But if you use lower than 7%, so this is the boundary, the border where the gas is flammable, it's completely unharmful. It's not flammable, it's non-explosive. So don't worry with this mixture, but you need to make sure that your gas supplier provides you with the right mixture. So usually here in Germany, we have the different colors of the caps, which indicates already the mixture. Also, when they deliver it, it's written on the sheet. So make sure that you get the right gas, and don't use gas which is 10% or even higher concentration of hydrogen. It will be dangerous. And also, hydrogen is completely safe to use in water networks or in fresh water. We have done also laboratory tested the hydrogen. It's no change in the water composition. So if hydrogen reacts, it usually reacts with oxygen, and then it forms HO2, H2O, no, HO2. And this is water, of course. So it's completely, yeah, the one which is also in the network. And it also doesn't change the water quality at all. So it's completely safe to use in drinking water networks. It's laboratory tested, therefore it's also recognized by the IWA, by the DVGW in Germany, to be a safe and secure gas to use in water networks. And like I said, one of the last resorts to pinpoint leakages. Yes, also for using it in the field, it's safe if you use the right mixture. It's also non-toxic. Nitrogen is with 78% in the background concentration in our air. So you won't get any harm if you inhale this gas or if you have it inside a pit. Yeah, so it's not yeah, dangerous. Okay, now about some standard application of the gas, which is important, and the slides you probably are most interested in. We use the tracer gas with a very high success rate in empty pipes. So usually what we do if the pipe is operated, we sectionize the section where we want to detect the leaks. Then we evacuate the water, we discharge all the water, and then we introduce the tracer gas. This is suitable for all kind of diameters. And you see here the positive effects is we have very high success rate, and it's suitable for all diameters. But the disadvantages of empty pipes, especially with large diameters, is we need to use a large amount of gas to find the leaks, or to make sure the gas escapes through the leaks and comes up to the surface and being traceable on the surface. And of course, another disadvantage is here that the pipe cannot be used for operation. So you need to sectionize, you need to interrupt the supply on this section. If it's not a redundant supply network, this is sometimes impossible, and therefore, yeah, we need another approach I will introduce later on. Yeah, this is a formula for you to calculate the estimated amount of gas you need to apply in empty pipes. So I have also written here some common diameters with the amount of gas per meter and 1 bar of pressure. So you see here already with the DN 500, you need to use already 300 liters of gas to achieve a 1 bar pressure inside. And we always say, especially with plastic pipes, that you should use at least the water pressure, which is normally in this section of the pipeline, to make sure the gas really escapes through the leak spot. If this is like lower than the normal water pressure, what might happen is, especially plastic pipes, they don't create holes. They create rather cracks. And if the pressure is lower than the water pressure, the leak is maybe closed. So there is no leak. And when it reaches the water pressure or higher than that, then the leak opens up and the water or the gas escapes. So this is very important for you to also know that you should always apply at least the water pressure. In pipeline still under operations, we say apply at least 0.1 to 0.2 bars more than the actual water pressure. So you would need to install a pressure gauge and see what's the actual water pressure, and then introduce the gas with 0.1 to 0.2 bar only. More than that, don't introduce much more than the normal water pressure. So for example, if the water pressure is 4 bar, don't introduce 8 bars of gas. This is also not very applicable and useful. You will need to use a large amount of gas as well, and also might harm the network. And also I will introduce it later, you will create big bubbles rather than small bubbles, and therefore the gas might not escape through the leaks when it's, for example, on the bottom of the pipeline, but on the if it's on the top, it's no problem, but on the bottom, the gas might not escape there. Okay, so the formula, just to explain you, it's the gas quantity needed. The VL is the volume in liters required for 1 meter of pipeline section. The length is the section length of your pipeline, and P is the pressure of the normal water pressure inside the pipe. Okay, now I want to introduce a new approach and a better approach for tracer gas leak detection. We now call it like it's an add-on technology to the tracer gas detectors. We call it gas diffusers. Formerly, we call it bubble creator, but gas diffusers sounds more sophisticated, I think. With the gas diffuser, we have a tool to diffuse the gas inside the water and create very small bubbles. And the small bubbles will travel together with the flow inside the section of the pipeline you want to detect the leaks, pinpoint the leaks, and escapes even on leaks on the bottom or on the side, not only on the top. If you don't use a bubble creator or a gas diffuser, it's pretty easy to imagine that you rather create big bubbles, and the big bubbles always stick on the top of the pipeline. If you're lucky and the flow is high enough, they also travel with the flow and they will escape through the leaks on the top of the pipeline, and then you can also detect them. But not all the leaks are on the top, as you know. Most of the leaks actually are on the bottom or on some joints or gaskets, and therefore you will need to make sure that those leaks also are able to discharge the gas and that the gas comes up at this position. So with this gas diffuser, you don't need to shut the supply, so you can leave them under operation. You have less gas you need for putting inside the pipeline. And like I said, the water carries the gas. What you need to make sure, and what is always the best, is that you have some certain flow velocity inside the pipe. If it's too slow moving the water, in the end, the small bubble will accumulate again and will form big bubbles, but it takes a while. Therefore, it's always best to have a high flow velocity inside the pipe. So if you have the opportunity further downstream to open a hydrant or washout, do that to increase the flow velocity if there's not enough consumption on it. And also, if you have the possibility to introduce the gas next to a gate or a valve, then partially shut this to create a lot of turbulence on this position to make sure the gas and water mixes well. Only if this is achieved, then also the small tiny bubbles will escape through the bottom leaks and come up at that position. Yeah, this technology is actually, or this approach is less suited for large diameter. Like, of course, it's also possible to do that, but like I said, with very large diameters, usually you have low flow velocities, and therefore the mixture of water and gas is not achieved in a way that also the bottom leaks will be possible to detect. And yeah, also with this kind of approach, the small leaks are harder to find. As smaller the leak, as less probability is that the tiny gas bubble also escapes through the leak position, and therefore it's very hard to almost impossible to also detect that. So for very small leaks and very large diameter, it's also sometimes a good idea to shut the supply and empty the pipeline and then detect the leaks in this manner. Okay, to go a little bit to the tool and show you what we have developed. This is the gas diffuser, what you see here in the picture. It is built in a way, so it's a very tiny stainless steel meshed filter. So maybe you know the application of gas diffusers for aquarium, for keeping fishes, to make sure they have enough gas to breathe in the water. This kind of sponges get used. So it's similar, but just much more tiny. So the pores here have only 10 microns. And therefore, you see here in the picture, I think it's also a video, yes. You see how the small, tiny bubbles getting created. And this is excellent to mix the water with the gas and create these small, tiny bubbles. And they will flow with the water flow, and the probability is much higher that this tiny bubbles escape through the leaks rather than you wouldn't use this gas diffuser. So if you don't use the gas diffusers, you will form bigger bubbles, and therefore they won't escape through the bottom leaks, and also not on gasket leaks on the side and so on. Therefore, yeah, the gas diffuser is a very nice add-on and tool to still detect leaks in pipes still under operation, and yeah, it's quite safe to use. So the gas diffuser is also, you see here, a water lock. We have a stainless steel tube where you connect then on the top your gas bottle, and the water lock has in the application can withstand pressure up till 10 bars. So it's absolutely safe. You won't get wet while you use that. And as I said, it's always best if you can use it, if the application, if the site is possible to install it like this after a gate valve or a valve, and you can partially shut that and create therefore a lot of turbulence there, and then you make sure that the gas mixes well with the water at that position. So we install it mainly on hydrants, but then the hydrant needs to be designed that you have a direct connection to the water column. And the other option is to drill the pipeline and to introduce the gas diffusers to the bottom of the pipe. So this is important. So you push it down right to the bottom and then connect the gas and introduce the gas when it is on the bottom. So usually the gas bubbles, they race, but if you have high flow velocity or higher flow velocity, I say we tested in a section of PVC visible pipeline. It should be at least over 0.3 meters per second, so that the tiny bubbles will flow with the water flow to make sure that they get dragged on. Okay, yeah, some other example for the application here in a training area in Iceland. It was a football, soccer area where they actually heat the grass to make it grow. And there we also introduced the gas where the pipeline was not possible to discharge. And you see here in this small video how the tiny bubbles come up. It really looks like sparkling water, and it's possible to detect the leaks here as well. Okay, this is about the tracer gas in water pipelines or infrastructure like pressurized infrastructure pipelines. But we also have some application out of the range of this. So, for example, here I have drafted and show pictures of tracer gas leak detection in flat roofs, for example, or on landfills. In landfills in Germany, at least, we need to cover them completely to make sure that the landfill gas, which is a very harmful, often sulfur polluted gases, which are very dangerous and very poisonous. So we need to cover them with a special shield to make sure that all the gas is collected and treated after it accumulates, and to make sure that the covers are completely shielded and secure, tight. Then we can also use tracer gas for checking where you have leaks in this kind of shields above landfills. And also flat roofs, often when they leak, you can also introduce the tracer gas in the room. You won't be able to increase a lot of pressure, but if you are able to step on the flat roof, which is usually the case, then you can fill the room where you have water ingressing with the tracer gas, and you go up to the roof and try to find the spot where you have the small cracks where the water can introduce. Okay, so I'm already finished with my presentation. We have now 15 minutes left for Q&A, question and answers. I see that there are already 43 messages in the chat. I'll just start from the first ones, which were written here.
Hi, Edmund. There's actually been a lot of chat going on while you've been presenting, which is very good. Maybe I can ask the questions for you so that you know, easier for you to go through them. First question from Alan is, how long does hydrogen last in the cylinders? And he's put 1 year question mark.
In the gas bottles, usually they also can be stored longer, but yeah, more than a year sometimes. But it won't be that the gas escapes completely out of the iron bottle, but the mixture is less, so you won't have 5% anymore, but after 1 year maybe you have only 3% less, which is still a good mixture to detect for tracer gas leak detecting. And also our tracer gas leak detectors, the M300 or the gas check, can detect as low as 1 ppm, it's 1 part per million, and 3% is 3 out of 100. So you see already, even with lower than 5%, if you use only 1% of mixture, you are able to detect the leaks successfully with lower concentration in the bottle.
Okay. And also there's another question from Alan, which is, are transport permits needed for the hydrogen cylinders?
This is a difficult question. Usually, yes, there is. Especially if you transport the cylinders inside a car and you don't have a shield behind the driver's seat, and your trunk is shut from the driver's area, you would need to make sure that you have enough ventilation inside the car that in the case the bottle is untied and the gas escapes inside the car, that you won't fade when the gas is spreading and the oxygen gets less concentrated because of the gas bottle inside. So usually, yes, you need a special, not a special permit. It's not that you need to go to here in Germany to the TÜV or association which is approving that, but you need to make sure that you have enough ventilation and that the gas bottle, when you transport it, is properly secured and safe. So don't throw only the gas bottle in your trunk and start driving. Then you might get into troubles with the road police or the regulators there. So you need to make sure the gas bottle is properly stored and that you have enough ventilation, then they won't say anything. But you don't need to go to an association to get a certificate to transport that. So it's not like a dangerous gas, like a flammable or a toxic gas where you have, for example, in the big trucks, which you see on the road with the special license plate for being able, if you get into an accident, that the firefighters or the police knows, okay, step away, this is dangerous. This is not the case.
Okay. And we have a question now from Stephen, and that is, would there be a problem with gas penetration when there are multiple pavements above the pipe? So I think what he means is, he says, meaning there are gaps between the cement pavement which could let the gas pass through in a different direction.
Yes, this is a very good point, and I didn't talk about that in my presentation, but thanks for that question. Tracer gas is actually very fickle and not very easy to control often. You need to know from the background of the physics of the gas, it always behaves in a way that it goes the way of the lowest resistance. Of course, I told you it will eventually diffuse also through asphalt or concrete or even steel. But it takes a much longer time. And if the concentration builds up beneath the asphalt, it will also travel to the side, because there the resistance is much lower, because maybe there is some gap in between the asphalt or between two layers, and the gas can distribute there. Therefore, it's very important to know this in your background, to not getting misleaded, especially if you go around with the sniffer and you find a very high concentration. Don't get overexcited and say, okay, dig here. Just think, what is the case? Here I have maybe pavement, and there I have asphalt. Okay, the asphalt is a harder layer to penetrate, so it will first come up through the pavement area rather than to the asphalt, through the asphalt, and therefore it's important to know that. Yeah.
I have seen some projects where people actually drill holes through the concrete and the asphalt at certain distances so that they can use the sniffer on those holes. Is that something you recommend?
Yeah, we recommend as well, especially on asphalt roads or concrete slabs. So this is recommended to drill and then use the sniffer above these drilled holes. Usually the road construction workers, they don't say anything if you have like 8 millimeter hole in the asphalt. Just make sure after you drill it and you didn't find the leak at that position where you drill, that you put some silicone or something inside that no water can penetrate inside the hole, because that might harm the asphalt.
Okay. We have a question from Vijay Kumar, which is, up to what time does the hydrogen traces available in the atmosphere to to confirm and verify the pinpointed area. So I guess he's saying, how long does it take for the hydrogen to get to the surface?
Yeah. Of course, it always takes longer as deeper the pipe is buried, as more solid and compact the soil is. For example, in the desert, where you have only sand, in the Middle East, for example, it won't take a long time. It will come up very quickly. Here, where we have a lot of limestone and lime, it takes much longer. And once it's up on the surface, there you need to be quick, actually. I mean, if you don't introduce the gas continuously, which I recommend if you do the tracer gas leak detection, then you need to be at the right time, at the right position to detect the gas. So if you are introducing the gas and stop, and then you go and detect the leaks, you won't be successful in with my knowledge, because when you come to the leak spot, the gas is already gone. If you're really lucky, you are at that time when the gas came up at the right spot, but yeah, don't believe in probabilities. Introduce the gas continuously, and then start after maybe. I always also have a good idea that you can check whether the gas is already could have arrived at the leak when you can open a hydrant or a washout further downstream, and you go there with the detector, and on the open washout or hydrant, either you see the leaks, or you can sniff the gas with the gas detector. And once the gas is there, you start walking on the section and you can pinpoint the position.
Okay. We have one question from Ian, which is, for a pipe diameter of 1200 millimeters, 10 kilometers in length, and a velocity of 1 meter per second, how much gas would be needed? But I think Ian put this question up before you came up with the formula.
Okay, yeah. I mean, with the formula, we use this for empty pipes. So for the pipes still under operation, you roughly can calculate with 100 less of gas when you use the gas diffuser and you introduce the gas while the pipe is still under operation. But with this large diameter, even with the gas diffusers, it will be difficult to detect leaks which are on the bottom, because in such large diameters inside the pipe, usually what happens, you have in the middle, you have the highest flow velocity, and on the border of the pipe material you have almost no flow velocity, and on that areas the gas will travel then to the section with the high flow velocity and will flow with the flow and accumulate also on the top, but they won't be able to escape through the bottom leaks in such large diameters if you use the gas diffuser. So this is still something you need to consider, that it's not possible probably to detect all the leaks in such large diameters with the tracer gas solution. Therefore, we also have developed the pipe mic, which is the tool to introduce acoustic sound inside the pipe. And yeah, actually the sound is moving on the bottom, so you will definitely find with these technologies the leaks on the bottom.
Okay, we got one question from Sushil, which is not really about what we're doing today. He said, hi, what technology equipment is used to find non-metallic pipes? So I don't know if you have any non-metallic pipe detectors?
Yes, we do.
Yeah.
In
So,
my first presentation, maybe I can
yeah.
back. Second. My first slide, I introduced about the pyramid mode and pyramid of success.
Yeah.
And here we have the PWG, which is a pulse wave generator. What it basically does, it introduces small pressure waves inside the pipeline, and this creates an acoustic signal, and the acoustic signal travels on the pipe material. And you see here the red dashes, so it very, very slightly makes the pipe vibrate, kind of. And you can detect this noise with a geophone on the surface. And where you have the maximum sound intensity, you will find the pipeline. And with this technology, we are able to trace plastic pipes, depending on the pressure, on the depth where the pipe is buried, up till 600-700 meters. We already achieved with this device. But let's say a realistic number is about 150-200 meters. If you have high pressure and not so deep buried, you can trace up till 700 meters. Yeah, possible.
Okay.
And also with the pipe mic, we call it 3-in-1 device. It's acoustic sound, but it's also in the same time a flexi trace, which is able to trace also the cable and the tip. And therefore, you can also locate the pipes if you connect it with a cable locator.
Yeah, okay. We have a question from Javier, which is, can we have a real demonstration on field using the gas? So I guess for anyone who's more interested in this, they can contact you or FAST directly. So for any
Which
possible...
country is from? Maybe we already have some service agents or distributor in that country. So
yeah,
might be interesting to know.
Yeah. So if for anybody interested in the products, they can contact you or FAST directly, yeah?
Yeah.
Okay, we've got a question from Brill, which is, will it affect the pH level of the water? And there's another question straight after from Syed, which is, will it affect any water quality parameters in the water? So I guess an answer for both of those.
Yeah. No, I spoke about that in my presentation. I will go to the slide where I talked about that. So we have tested with GeoChem. It was a project which we had in the Middle East, in Dubai. And they, DEVA, during the time, or the water authority in Dubai, made us or asked us to provide a certificate that the gas is absolutely safe. So we did that, and also since it is recognized by the IWA and even the DVGW, which is the German regulation for the water authority and the gas industry here in Germany, they also testified and said it's absolutely unharmful. It doesn't change any water properties physically and chemically. So no pH is changed, yeah, and the water quality stays the same.
Okay. We have another question from Stephen, and I think this comes back to one of your slides when you were mentioning about small leaks are difficult to detect. And he said, how small is a small leak, which is difficult to answer. And his second part of his question is, and would this be feasible for pipeline pressure below 1 bar?
Yes, for pipeline pressure below them bar, tracer gas is absolutely the last resort. Is also with pipelines with uninterrupted water supply, this is the last resort, because you won't be able to use any acoustic technology to detect the leaks. Therefore, tracer gas is the last resort in these cases. And for the question of what's the first question again?
How small is a small leak that you can't detect?
A small leak is about 1 millimeters or lower, but also like we call it sweating gaskets. This is something which is very difficult to detect. Even with tracer gas, what you would need to do there is to shut the section, empty the pipe, and then introduce the gas into the empty pipe. And then you will also find these sweating gaskets, which are in Germany, actually, I have a lot of cases where they have newly constructed pipelines, and in this, they didn't succeed with having the pressure test done successfully. And then we usually get called like, okay, the construction company, they are responsible for that. They call us, and the pressure test is really a very sensitive test. It detects trips. Normally the water authorities, they won't take the new pipe if this test is done successfully. And then we use the tracer gas for detecting these dripping, very small sweating gaskets or joints. And yeah, but there we are also able, because it's newly pipelines, to empty the pipe and to introduce the tracer gas.
Okay, we've got a comment here from Theodore, but it might be interesting for your comment as well. It says, need to pay attention to the wind on the surface. If it is too windy, it may push the hydrogen molecules away from the path of locating.
Yeah. Therefore, I mean, we have two different designs of sensors. One is a hand probe with the sniffer on the top, which is getting used in the air. And we have a belt probe, and the belt probe has a rubber piece which firmly presses onto the surface, so it's shielding the area where it sucks in the gas, and it only sucks the gas from the surface, from the material on the surface. And therefore we make sure, even if it's a windy day, that the gas is detectable on this position. But of course you will need to keep the sniffer on that position for a few seconds longer to make sure that the concentration is able to build up again before, because when you first put the sniffers there and the wind was blowing away all the gas before, it needs a little bit more time that the concentration builds up on the position where you put this sniffer rubber piece.
Okay, we have a question from Craig, which is, if the diffuser needs to be in the pipe, does that mean it can only be used from an external boundary box, or can it be used in line between the bottle and a point of connection? So I suppose the question is, how do you put the diffuser into the pipeline?
Yes. No, on a boundary box, it won't bring you a lot with the gas diffuser. Then it's a rather good idea to have a water tank where you also can introduce water and gas at the same time and make it reverse inside the pipe. Because if you only put the gas diffuser on a boundary box, usually the flow is towards the house. But you would need to imagine that you need to push all the gas through the house connection into the main, to the street. And in this principle, the gas diffusers won't push the small bubbles water mixture, but only the gas. So the gas diffuser only brings you something if you install it on the main directly, either through a hydrant or a hot tap. So you need to put a drill saddle in Germany, or especially in the area where we are located, we are very lucky here. Actually, we have manholes where you have all the different house connections going to the different houses. And there we can directly put the gas diffusers on the hydrants, which are situated on the center of the manhole. And yeah, also you have a gate valve next to it, so you can also create a lot of turbulence on the position. But on the boundary box or other positions to introduce the gas and to make sure that the gas arrives in the main pipe, this is not a tool which I would recommend. Then you just push the gas regularly without the gas diffuser and you have the same effect.
Okay, we've got a question from Gilberto, which is probably not easy to answer, but he said, is it expensive? Say our valve-to-valve distance is 500 meters and the pipe is PVC 300 millimeter. So I suppose price-wise, it would depend on how much gas costs in his country, and if he's only going to do 500 meters, then buying the equipment to do it's going to be quite expensive. So the more you can do, the cheaper it becomes per meter, I'd have thought.
Yes. Since tracer gas is really the technology of the last resort, when all other technologies fail, usually those are leaks which run already a very long time, and the water companies are willing to pay also a lot of money when you are able to detect those leaks. So therefore it's something where you can specialize in, and if you are a service provider or related to this business, then it makes often sense to specialize in those specific area, and you will still earn good money, even though the technology is more expensive, because you need to buy the gas, you need to carry the gas to the side, you need to have the machines as well. But in the end, I don't think it's more expensive than having a correlator, because a gas detector normal cost is about between 3,000 and 4,000 euros, and the gas per cubic meter we buy here in Germany, a bottle with 50 liters and 200 bars, so it's 10 cubic meters, 10,000 liters of gas for about 30 euros a bottle. So it's not a huge cost you have there.
Okay. We're still getting lots of questions, so as long as you're happy to answer, yes, I'll go through. The gas probe, does it need changing? Is there an interval that it needs to be changed, or will it last for a long time?
Yeah, the sensor of the gas detector is a physicochemical cell. So as more you detect with the as more gas you sniff with the sniffer and the sensor, as more it gets worn up. So but doesn't mean that it is not operational after a while, but it's less sensitive. So you would need then higher concentration to still detect the gas, because it won't be able to detect 1 ppm anymore. So it's also always recommended from our side, if you use the gas sondes in very high concentrations, once you detect the very high concentration, go out of the area with the sensor, let it refresh so that it recovers, because if the cell is exposed to the gas for a very long time, this will makes it worn down more quickly.
Okay.
But let's say we change here between every 2 and 3 years the sensors. if it gets used like once a week or something like this.
Okay. We have two questions, which I think one from John and one from Ian, which is basically the same question. Are there specifications on purity rate for hydrogen and nitrogen, for instance? Normally the gas has to be food grade quality.
No, no, no. This is a very good question, and thanks for that. I didn't talk about that yet. We have 3 different grades of gas we can use. The first is gas which is used for medicine purpose, so for laboratories. And this is a very, very specific defined gas. And if you purchase there the 5% hydrogen and 95% of nitrogen, it is really 5% and 95%. And the 5% is 5.000000. And this is 100% exactly, because it needs to be like this for their machines where they operate, like the detection, the gas chromatographs, for example. So this is very expensive gas, and 10,000 liter bottle you will get probably for 200-300 euros, which is absolutely not necessary. The second grade is also a very defined gas, but we always use the last grade. The chemicals inside are always the same, but we don't need to have the very defined mixture. It doesn't matter for us if we have 4.8% of hydrogen or if we have 5.2% of hydrogen. As long as it is more than 1% or even less than that, our, like I said, detector can go down to 1 ppm, 1 part per million. So it should be far enough to detect such a concentration. Doesn't need to be specific in that purpose.
Okay. There's another comment from Javier, which is, we would really appreciate if one day you guys make a real demonstration on field using gas. We have many clients that would be very interesting to use that tracer gas. So maybe we can get you to contact with Javier afterwards.
Yep.
We've got a comment from Vijay Akuma again, which is, in developing countries, the atmosphere has got hydrogen traces already exist due to emission of H2S gas from open drains, nearby manholes, as well as from traffic. Surely the sniffer will give leakage alarms, which will guide us wrongly. How to deal with this?
H2S is actually not sensitive to our sensors. We only detect pure hydrogen, H2. Yep. And the background concentration of diesel engines, I already explained how to proceed there. So you just, when you have such a cloud in an old diesel engine, like I know in developing countries, there are a lot of old trucks which emits a lot of fine dust and also hydrogen, which is not like a huge amount of hydrogen, but it's something you can detect. I have done measurements in India personally, and on a road which was very busy with old trucks. Every time an old truck came, I had about 20 ppm, 25, 30, something like this. But if you have a leak, usually the concentration, if you are on the spot, goes up to over 999. So this is the maximum reading of our devices. So it's much higher than the diesel engine. So you just stick on the position where you first see an indication of racing numbers. You stay there and see if the number either increases or it decreases. When it decreases, it was not a leak, it was some gas cloud, hydrogen cloud from a diesel engine.
Okay, well, you'll be glad to know that's the end of the questions. And I see that Kurt has put your email address in the chat as well. So hopefully people can see that email and can send you any further questions that they have.
Yeah.
So thank
add
you
it here
very
in
much,
my
Edmund.
presentation.
That was a very good presentation and something new for a lot of people. So very interesting. Thank you very much
for the opportunity to talk here, and great webinars, great achievement from the IWA. Thank you very much.